Welcome, everybody. It is Dave Cooper, and we are streaming live from the motorhome. It is a product spotlight. We are on our way south. South. Can you believe that we're south of Virginia, and it is still only 32 degrees? Regardless, we're going to heat it up because we got a great show for you today. I'm Dave Cooper, davecooper.live. Please join us. We are live on LinkedIn, YouTube, Facebook, and Twitch. What is happening, George Ryman? Good to see you out there today. Today, we're going to revisit Roger Krulak, Full Stack Modular. It was a great conversation that we had. This is going to, if you haven't seen this, you need to watch it. You need to watch the Parametric Design and understand all the technology that they have been putting in place. But first, before we get into everything that Roger is doing, at Dave Cooper Live, we are bringing you the people and the processes that are building it better. Our guests in topic include experts in building systems to building science, building codes, and the tech used to build it better. We are seeking out the best and the brightest in construction and discovering all the ways that innovative buildings come to life. Before we go on any further, let's thank our sponsors who we love very much. Forward Solutions Group, Ben Hershey and Joe Butler. They are a team with more than 175 plus years of experience developing and specifying manufacturing for panelized and volumetric modular industries with best practices in development and implementation. They offer consulting to investors, developers, manufacturers, builders in using offsite manufacturing methods. Forward Solutions is driving companies to succeed where others have failed. Please, if you want to learn more, reach out to Ben at forwardsolutionsgroup.com, or you could reach out to Joe as well. So, all right, let's hop into it today. Thank you, everybody, for joining us. We are in transition period. We have our ride. We have our show set up. We are hitting the road. This is a travel week. This is getting everything put in place. So thank you for joining us today and bearing with us as we get this road show kicked off. It is going to be a ton of fun, and we are going to visit all kinds of people across this great country, and hopefully we're going to visit one of you as well. All right, so with that said, again, today we're going to get into today's instant replay of Full Stack Modular with Roger Krulak. Let's hop right into it. Here we go. Roger.
Hi, Dave. How are you today?
Yeah, I'm doing great. Welcome to the show.
Thank you so much, and thanks for having me on. I'm really looking forward to the conversation.
Yeah, well, I've been, and I told you previously when we talked that I've been looking forward to this conversation for quite some time, and I think you're going to bring a lot of experience and know-how to this conversation, which is great for our audience. So, before we get started, I ask everybody, I want to know everything from the moment you were born to this very moment in time, all within the next 3 to 5 minutes. Don't leave any of the gory stuff out. I want all the good stuff, man.
Sort of a perfect question. If you look behind me, that shoulder. If you look behind me, that's my great-grandfather, Joseph. He was a carpenter born in Russia and sort of made his living as a carpenter. And I keep him on my wall because he reminds me that if I brought him onto a construction job site today, he would be as comfortable as he would have been 65 years ago before he died. And I keep reminding myself and our team that we have to continually innovate because we've been so slow at the same thing. So that is one of my drivers and constant reminders about how to think about changing the creation of the built environment. I've been in construction and development most of my life, little short time in the restaurant business, but most of it in that. And I've spent the last 13 years now on what is now Full Stack Modular's quest. And I have, anybody who knows me knows that wasting time, wasting money, standing in line are things that drive me crazy. And I have been incredibly focused on finding a better way to create the built environment. I have been focusing specifically on design, manufacture, and construct multifamily buildings for a dense urban environment. Mid to high rise. That's really where we live. We do other stuff, but that's really where we spend most of our time. reason, from my perspective, is need and market and complexity. I tend, even when I had my own carpentry company, we did the most complicated projects possible because I think that there's value in being able to figure those out. And so I've enlarged that to sort of how do we figure out how to make this industry a better place, whether that is a specific building that is quite complicated.
Yeah.
And so I've spent the last 13 years trying to find ways to take advantage of the economies of process that manufacturing has in all other industries and move it into the construction industry and move its colossal infrastructure, which is happening now globally, and even in the United States. I say now globally and even in the United States, which makes me sort of smile. And that's what we do every day. Every day we have the opportunity, having been in construction for a long time, the advantage of being in a factory is you can see how it's done every day, and you can decide what's not working and how to fix it. The advantage of being in one place when you're building buildings from multiple locations.
Yeah.
So as I explained, Full Stack Modular is a design, manufacture, construct solution. So we create with developers and architects, we create a product that meets the needs and program of the developer. We then create production drawings that create very specific instructions for moderately skilled people to be able to create incredibly high quality buildings, consistently dimensionally accurate, and meeting the needs from quality, finish, look, feel in the factory, and then through our process organize and control all of the dimensions so that the building that we're building in the factory fits on site. The interesting thing about you talk a lot about digital twin. There is no option when you're building off-site other than to have a digital twin, because you're building it in an environment that it's ultimately not going to rest in. So if it's not accurate, then the building's not going to be right. So there's no way to sort of fix it. So if you build it wrong, it's going to be wrong. And so our process is so different than what people are used to. The whole idea of either level of detail or sort of design development drawings to DDs, to DDs plus, to construction drawings, that's not even in our world. The idea is, how do we get everything organized, coordinated, and created into a series of pieces that creates the whole building and all the systems associated with it.
Right. So, what's fun about this, just watching the smile on your face while you talk about it, right? So, I mean, you can tell you have a true passion. But before we jump into the entire process, mid to high rise, what does that mean to you? So the audience knows what you're talking about.
I live in New York, so mid to high rise to us is sort of 12 stories to our system in a non-seismic zone can go up to 45 stories in a double loaded corridor and up to 65 in a tower configuration. By the system that we have today. We are also now working on a mid-rise in Los Angeles with all of the seismic requirements. So that will be going up. Next year. So that system should get us to about 25 stories without too much of a problem.
Yeah. So everybody can understand. I'm just going to show you your site real quick. I mean, we are talking mid to high rise, beautiful buildings, and you're building out of steel.
Mm-hmm. Yeah. So we are a all steel. It's actually a Verandil truss system that we created in conjunction with Arup Engineering and have been perfecting it year after year, solution after solution. And like I said, we do stuff that's a little bit smaller, but it really is focused on sort of mid to high rise buildings. We think that that's where the benefit of the economies of process really help.
Sure. So, all right. So, I mean, mid to high rise, this is a whole lot of structure. We're building it offsite. You're building it very dimensional and accurate using the labor in a controlled environment. So all those things we all understand from a, modular volumetric side of this. What I think you guys are really doing differently is you're using technology in a much different way to get a project started and all the way through the completion of a project. And I think that's a really strong talking point for today is, let's talk, how do we get to a digital twin? Like, we start with a digital twin, but you also end up with a very advanced digital twin at the very end of this.
So I think the answer is pretty simple. It's one of the things that I think many humans do is that they create a system and a process for doing anything in their lives that requires them to be disciplined to a good result. So if you think about building off-site and coordinating the process, anybody who's been on a construction site or on a construction job, no matter what you do or no matter how we develop our process, we have all of these interfaces with the different sub-trades and the structure, and ultimately we end up in areas where we have to deal with clash and coordination, et cetera, so on and so forth. And it's a virtue of that we don't take the drawings to a level of detail that's high enough so that we don't avoid those because we're in a hurry, because it's taken us so long to do the drawings, and B, because you can actually deal with it. But if you think about what we do here is we build the building and all the pieces associated with it right here in the factory, including the mechanical and electrical distributions, the structural connections, the diaphragms associated with it. We install the facades here, all the hallways, all the shafts. So everything it's all one piece at the end of the day. And if you don't solve that here, you can't actually create anything there. And the field conditions are, let's throw away a part of the building and start over again, or tear it apart, which of course nobody's interested in doing, and not the way we think. So if it does not live, having been in the construction site and been a superintendent and run carpenters and do all that stuff, and I think about sort of my angst in running a job, in a big high-rise building when I had to do the carpentry or whatever it is, and I think about the intensity with which most trades and people meet that kind of process.
Right.
We do have some of that, but really where that exists is when we're building the model, right? The building the model, when I get a set of model drawings for a first pass, I'm screaming, why isn't this right? Where are the dimensions? Why aren't they in this location? How's anybody going to build this? What's going on? So we're imagining the process as we create the drawings. And the drawings are, in our world, not broken down by trades, but broken down by tasks, sub-assemblies, and assemblies, much like any manufacturing process. So all those things have to come together. Not only do they have to come together and fit dimensionally, but they also have to come together in process. So the things that you're doing before something have to fit into the things that you're doing after something, that ultimately ends up in a component of the building, which we call a mod. And then those mods have to go together. Otherwise, it doesn't work. So when you think about the building from the bottom up or the inside out, it is very much that. So without it, you're lost. And to me, the thing that we've spent a lot of energy on, people talk about automation, but we spent a lot of energy on is metrology, the model-based surveying that we do both here in the factory and on site to ensure that everything is built to very good construction precision and what I call sort of miserable manufacturing precision. We're bridging that gap. Although our chassis, the structure of the building, are measured to 0.02 of an inch, everything else ends up somewhere in a quarter inch. And if you think about the way we think, everything has to have the same tolerance. There's nothing that can have less of a tolerance because they're all done in pieces. So you can't have the MEP system have a 1-inch tolerance and the steel chassis have a 1/2-inch tolerance, and then the fire sprinkler have a 2-inch tolerance, because then nothing goes together.
Well, I mean, you take a 1/4-inch tolerance. By the time you get 65 feet up, that's a couple feet, right? If it's not accurate.
Yeah, exactly. And more than that, if you have a variance between the tolerances between systems, you have this problem. It doesn't work. So everything we do is of the same process. And you can liken it to anything you want, like a car or a ship, et cetera. It all has to come together. And go on.
Yeah, I was going to say, so let's talk about how this process actually comes together, right? Do you guys do all your own in-house design work? And I know I want to jump into this whole parametric design that you're working on in your website, but tell us how it starts, with you. Are you finding that you're taking somebody's plans and having to modularize them, or are people actually coming to you and you're putting it into your process?
See, I was smiling and laughing, and now you're going to get me in a bad mood, because there's nothing worse than hearing somebody wants you to modularize a building. I mean, it's likely not going to work, and B, it's likely not going to be cost effective, and C, it's likely to be a headache. And it's interesting. 3 years ago, we did far more of that than we're doing today. It is more common for a developer to call me up and say, I really think I want to embrace the modular process. How do we create a building that works for my customer needs and my program this way? And then we actually, regardless of the architect, and we work with some fantastic architects, regardless of the architect, we take that program and we take that program and we use our process in order to mass out the building and at least come as close to the program as possible. And then we share that with the architect, if there's someone other than us. And they're already starting with something that is already mathematically accurate, that it incorporates our floor to ceiling sandwich, our wall systems, our intended MEP distribution, et cetera. So rather than just, and this is something that grates me more than anything, thinking that every building built is different than every other building built is just not the case, but we all treat it like that. It's like, oh, we're going to build a building. It's going to have walls, and like we need mechanicals, and that's just not true. So why can't we embrace the fact that this is all a set of subassemblies that create a building, and we've built them before, so why can't we use them?
Yeah, absolutely. Well, listen, everybody, if you are just joining us, we have Roger Krulak on, and we are talking about Full Stack Modular and how they do things. So it's fun to watch. We have a lot of people lighting up the conversation already, Roger. So I think we're going to have to pause here and there and start taking some of these questions, because by the end of this, we might be here for a day.
Okay, whenever you like.
Let's say a couple quick hellos. Who's coming in here? All right. Well, you might know this guy, Roger, my favorite volumetric manufacturer. Excited for today. What is happening, Joel? Well, I know Joel loves it because Joel loves parametric design.
Yeah, right. I'm a huge believer in sub-assemblies.
Yes, he is. Chris Roush, looking forward to this one. Anthony Good, testing. Are we all? We're all live. Yes. All right. Sean St. O'More, happy Wednesday. Let's get down here as we Henry Mickelberg from France says he has popcorn for this one. All right, getting down. I know I saw some questions in here. All right, so we got Andrew Seeley joining us, and we also have Prudence. Lead silver is a good start, but you can do much better. Parametric modeling and leveraging big data to minimize risk and cost is my jam too. Have you considered passive house level performance, Roger?
Yeah. So yes, I know that lead is a good thing, and yes, we've done designs for many developers that are passive house leaning. Passive house certification on a full building modularly does have challenges. It's possible, but the units are incredibly tight. And yes, the designs, incorporating ERVs and highly sustainable envelope, etc., is something that we absolutely do and can do. And I believe in it. Frankly, if you think about it this way, one of the most complicated things to do is mechanical engineering, because the assumptions you have to make are always inaccurate. People loading, sun, cold weather days, all of those things are always guesses and then inaccurate. So if you can make your building as thermally tight as possible, it's a much easier process and a much more comfortable building. So we push, we push our customers to think about that and spend the extra money in order to do that. And interestingly, in modular, the extra money is basically the material cost. If there's an additional material cost, it costs a little more. Everything else is normal process for us. We can install anything. It doesn't really matter.
Right. Perfect. Thanks, Prudence, for the question. Anthony Goudet says Roger Krulak is a great example of a fabricator that gets it. All right, another question. Henry Mickelberg, are you experiencing the same really annoying situation I've been struggling with in the US, where we've got a fully integrated multi-D digitized module, and we then have to ridiculously unpack it to accommodate the architects of record sign-off? Question mark.
Oh, gosh. So I just told you, we're sort of trying to train the process. Sometimes it's easier than training the architect. And the answer to your question is that we are asking them to deal with our models nowadays. And yes, sometimes we have to find ways to demonstrate them to the architect, but we really don't. We really try to control it from day one and make sure that they're on board with it. And we're finding pretty good pickup on it when they know they don't have to do the work, but they know that they can get what they need. We can have a 5-hour conversation about the word shop drawings and what it means in modular, because I don't really understand. If they design something, we're going to build it that way unless we tell them otherwise. But so that's my most annoying thing, is just like, shop drawings, just look at our production drawings. It shows you where everything is with absolute accuracy. If you don't like it, let us know. Oh no, but we want you to. So that's my pet peeve, but of course it exists.
I want to keep Roger smiling. Let's keep him in a good mood here.
Yep.
All right, here's another question from Chris Roush. What technologies are you leveraging for metrology in the plant? LiDAR, laser tracking, others? Really interested to hear about that.
Yeah, so in the factory, we use some aerospace technology. It's actually a Nikon product that also has a real window associated with it. So, and it's relatively automated. So it knows, it has the models built into it, and we have the plant as a grid, and then it checks the theoretical against the actual and allows us to adjust in the event that there is a differential. On site, we use an advanced or modified version of a product used by SiteAware, which can either use drone or sort of measuring stick technology on site that does the exact same metrology and gets with our mods. We actually put monuments on our mods to allow the accuracy of the scanning done on site to get as close as we needed to, rather than what's sort of normally required under normal circumstances.
Perfect. Great answer. All right, moving on. We got Willy joining us. Bare Naked Willy, big thumbs up to Roger Krulak discussing Offsite live with our PH friends. There you go. Passive House, folks. I love it. All right, so moving on down the line. All right, we're going to have one more. We'll let Joel give you a loaded question, as he puts it. Slightly loaded, I should say. Do you, or are you looking at doing more sub-assemblies yourself?
Yes. So Joel, we do a lot of sub-assemblies. What we are looking to do is to make sub-assemblies a product offering. And Joel knows that very well. We believe that as this industry grows, and it is going to become more and more possible to integrate sub-assemblies manufactured by others in your process. Modular right now is pretty bespoke. and everybody has a system. You know, we have ours, and others have theirs. But the idea of being able to create an integration of the subassembly process, much like Splash Modular, you can incorporate those into the process, and we fully intend to offer that as a product in the coming months. So.
Very cool. Splash Modular. Love it. All right, Joel, thanks for the question. We'll just say hello real quick. I don't know if you know John, but I believe you do. Hello, Dave and Roger. John.
Hey, John, how are you?
He gives me a hard time. So his name is John Bongiorno.
Buongiorno, yes.
I could never get it right. All right. So let's hop back into this, Roger. Let's talk about what's really unique about where you've headed with the parametric design in the process, because walk us through, I mean, even your website, you want to walk us through, you can design right on your website what you are looking to build before even talking to you.
Can we walk through it?
Go ahead, put up the shared screen and we'll walk through it.
Let's see. There we go. That should be it. Can you see it?
Nope, not yet. Hit the share button.
I did, but let's try again.
Hit it again. All right.
Chrome has lost position to capture. Chrome has lost permission to capture.
I can share it from my end if you want. Just let me know.
Yeah, it doesn't seem to want to let me do it. I did something wrong.
Nah, it's all right. It's live. If it's gonna go wrong, it will. That's just the way it goes, right?
If you want to share it up, then that's even more fun, because then you can do it rather than I. So.
Oh yeah, me try and work through it. All right, here we go. Let me pull it up for you. Is it it's the planner, right?
Yeah, just go into the design slide, and we can just walk through the design slide, and then we can. Yeah, but let's go up first for a sec before we do that. You should be able to. No, I mean, like go up on the website to where it explains the design process.
Oh, I got you. Okay.
Perfect. You do walk through. It's a good conversation. So.
I know exactly. Sorry, everybody. Let me just get the design portion here, and we'll be able to pull it up right now.
Fantastic.
Okay.
Fantastic.
There we are.
Okay, so yeah, that's perfect. So our process is really a systemized approach. And the systemized approach is really based on the program. If you want to just scroll down, Dave, thanks. So if you imagine that everything is created out of a component or a subcomponent or an assembly or a subassembly, we think about the whole building that way. And then obviously we have our own chassis design that allows us to do that without too much rethinking. So let's go to the next one. So if you think about the fact that a building is made out of, in our view, flexible components. And so you have components that are both utilized sort of as a unitary or in combination with each other. And the goal and the way that we think about building our buildings is, what is the minimum amount of components that you can use, variety and complexity, to meet the needs or the program of the building of the owner. So that's the key to this whole process. How do we create something that works for everything, but is as little variation as possible?
Right.
So, yep, go on here. So basically here, what this is doing is there's roughly 4 or 5 different module types, even though they're actually all in the same size, they don't have to be. But you can see that from those types, you can make 1, 2, 3 bedroom units, and you're combining basically all the same stuff. It's very effective. It's very flexible, but it's also organized, and it's organized in a way that it can be built faster and repeated accurately, and obviously create a huge value proposition for the sub-assemblies that are going into it, because they're all the same. They're unitary as much as possible.
Right.
Okay. So then you take those unit combinations and you mass out a building. So you start with the basic, and you can really create a building pretty quickly, at least on the conceptual basis. That which takes architects, as much as I love them, often a really long time. We can do it. Well, we're going to do it right now. So go to the next slide. This is basically the way we think, and what Joel, yes, stay here for 1 sec. So what Joel had mentioned, if you think about it, our kitchens, our bathrooms, even our facade is a subassembly that's manufactured either here or elsewhere, and then integrated into our assembly, which is the units or the portions of the units that create the building at the end of the day. So Dave is going to design a building.
Oh, look at that. Perfect.
Okay, so if you hit that, try this design tool yourself.
Yep, let me do this here. I got to go back into a different screen share for that. All right. Yeah, it's one of those beautiful things that we have on this system. All right, here we are.
Great. So let's just take a typical building in New York. I don't know, Dave, let's build a big building. So, I don't know, make it 100-foot wide. I don't know where you find a piece of land in New York that's 100-foot wide, but that's fine. And then typical residential building depth, 70 feet, right? So it's pretty typical. It's never more. But let's go moderately tall. We said mid to high rise. So let's just say it's 150 feet tall. Yep. Okay, so now you see the way that it's laid out. Now, the next thing that you can do is you can say, look, how wide do you want your units? So a 14-foot 6 wide mod in a 1-bedroom is going to be awful big. I mean, for New York, that would just never happen. But let's just say we're talking about Queens. It doesn't have to be New York micro units. So let's just say we're going to do an 8-bay count. Just choose that little 8-bay. There you go. So now you have studios, and now you get to choose what the mix of the units are. So just click down the different unit combination. You can see that the building's changing as we click the, how many percentage, 1, 2 studios, 3 bedrooms, etc. So let's just say we're gonna trend towards let's just take the number 3 right there, because we're gonna trend towards smaller units, but we'll have a few mixed. So if you hit the dot. Yeah, the third dot, just the third dot down there.
Third dot down, got it.
Yep, there you go. So, and now you get to choose what floor height everybody's going to ask me, can you change the ceiling height? Yes, you can. I mean, it's no problem. And, a 9-foot ceiling is pretty nice. So if you say we get 14 floors if we use a 9-foot ceiling, we'll get 15 floors if we use, an 8'7" interior height. But let's just use 14 because it works quite nicely. And then, so now, yep, there you go. So there's your layout. Now hit the massing. Yeah,
wow.
Now you want to go out. If you can, you should scroll out. There we go. Okay. So now, I mean, we have lots of facades, but hit traditional, just to show what okay. So this is in a more traditional setting, and you've got your building massed out. We know know how many mods there are, how many units there are, how many bathrooms, how many kitchens. We know a whole lot of information about what you want as the building designer. You're an architect now, Dave.
I love it. That was easy.
Yeah, and then hit the units. Hit the units there.
Yep. Yeah, I'm trying to. It's not going. Oh, there it goes.
There we go. So now, just hit the studio. Yeah, you guys hit the studio button. So that's what our studio looks like in this parametric modeling process. Now, 1 bedroom, 2 bedroom, 3 bedroom. You can see how it just scroll over to the right. Hit 1 bedroom now. Yeah, just the 1 bedroom key. Yep, there you go. And now 2 bedroom, 3. Whatever, just to give you some. Yeah. So now you're seeing that we're taking all of our parameters, all the things that we've created, and we're creating a solution. So now if you hit one of the green buttons on one of those rooms there. Yeah, that's a bathroom. That's a tough one. Have you ever tried to take a picture of the bathroom? So just take like one of the, there you go. So now we're looking outside the window, and obviously you can dress this up as much as you want, but what's worth knowing is, scroll around, you can look at the kitchen, etc. door, you should hit door, and then, oh, this is the interior door of this.
Let me go back and then I'll.
No, it's all good. So I think what we wanted, go to the one that just doesn't have it doesn't have an interior wall, like the next one over. You got it. That's a bedroom. Yep. So now, go around, you'll see the kitchen, etc., all masked out quite nicely. Now, just stay right there for a sec. Now, let's just say, I like the way that this looks, but it's certainly nice to be able to add a floor if I'm a developer, because I want to get as many units as possible. So now go down to the floor option and hit 15 instead of 14 at the bottom. And there you see, I don't know why it's weird that it's not responding. Welcome to.
Well, we're putting out a lot of CPUs right now with the live. So.
Well, anyway, if you want to play with this yourself, basically it's going to shrink the ceiling height.
Yeah.
And if you hit 13 floors, it's going to raise the ceiling height. And then if you change, there you go. And then if you hit the bay counts, like change it from 7, go to bay count and change it to 9 instead of 8. And then it'll the next, there you go. If you not there, up
not there.
Modular configuration. I'm sorry.
Oh, I see it here. There you go.
So now it's going to shrink the width of the rooms so that you can see if that's going to sort of feel and look the way you'd like it to. Anyway, you get the idea. Like, all this stuff is stuff that people think about all the time. You actually have a tool to look and see what it might look like. Right. Exactly.
Wow.
So,
perfect. Go ahead. Keep going.
No. So then if you think about this, like, all of these things are already created in our process. So the result of it is that you can create a building, price it out pretty quickly. I'm sure John Bongiorno's pretty excited about this. I mean, that's definitely something right up his alley. We know everything that we can about this building and what the developer wants, based on, sort of their own interaction with the building itself.
Right. I love it. I think this is absolutely amazing. I'm even looking at myself here to see if I'm freezing up. You can hear me all right, but I think my camera's freezing up now.
Your camera's,
Yeah. It takes a lot of, a lot of bandwidth to pull that going forward. I'm going to actually make a switch here, see what's going on. That's the first time that ever happened. Let me see. All right. So with everybody can hear me okay though, right? So as I work through my camera issue, I'm not sure what's going on with that camera. Tell us a little bit more, so now you've designed it into this process. How does it now work for moving forward?
Yeah. So, I mean, we get a bunch of data from that. And our goal is that this parametric model will ultimately get input into our estimating process.
Right.
So we literally should be able to turn around and give somebody a real number for that building the way it looks today, tomorrow.
Yeah.
And I don't mean give them a price tomorrow. I'm talking about give them a price now for what it looks like tomorrow, obviously with some parameters, et cetera. Yeah. So the interesting thing about that is, as you can guess, all of those things can be sub-assemblies, which not only do we know the process, but the manufacturing time and the finishes associated with it and what the options are, et cetera. So, over the next few months, look for something that's even more, I like the wood engineered floor, or I prefer a Duravit, fixture, et cetera. So you have all those options of really creating buildings on the fly.
Well, listen, I've been doing this live stream for a long time. That is the first time that used up so much CPU during my stream that I never froze. So there's a ton of data behind what's happening there, because that rendering tool, I mean, it takes, that's what it's doing. It's rendering it on in my computer, and it was eating up my CPU. So definitely cool. We just proved something. There's a lot of thought behind that.
Yeah, a little bit.
All right. So we have the design. Walk us through. I mean, the ultimate goal on these buildings, right, is one, the efficiency of it, and obviously the speed of construction. But at the end, you're not done there. When this building is built, you're still collecting data. You're still using the data, the digital twin to pull all this together. So here we went from the design process. We know the manufacturing process. Now you're installing. But during the install, I mean, you guys are using data sets on this whole thing, correct?
I mean, well, we talked about the dimensional accuracy and associated with that. And what we have we like most of us call these things mate lines, like the mate line drawings that drive the information where people know how they're building on site. With an eye towards, augmented reality in the process, making everything simpler than it possibly could be. That model allows you to drive that. And not only does it allow you to drive that, but it allows you to drive maintenance and monitoring and sort of forward-looking building operations and the way that they're created. All of those things are available because the data is already there. Even I get calls about buildings we built some time ago where they want to know if they can, combine two units or et cetera. And normally you hire a structural engineer, you pull drawings from the city, but we have a digital model. So we just say, look, there's nothing here and there's nothing here. You can do whatever you want. Right.
Well, I mean, it's powerful. Even John Buongiorno, Axis Construction, they're in the commercial space as well. He wrote, "Thank you for stating that this process is a complete program that one needs to understand and embrace in order to move forward with offsite construction." Great job with this, Roger, as he said. And he also said, 100%, Roger, I will be calling you in the next day or two. All right. You know what? You gotta love John.
Exactly.
All right, here we go. Let's keep going. David Flynn says, Roger, is this tool connected in any way to your internal fabrication tools or processes?
Yeah, so it is increasingly so. It started out, like most things, as a way to deal with the complication of getting somebody to understand what it is that they want, and then to turn it to that. It is now connected to our estimating process, and our estimating process is actually connected to our ERP system, and then of course the ERP system ultimately, hopefully, soon we'll be able to communicate machine code associated with all of that. But that's the ultimate goal. We're not there yet, but we're getting there.
Right. So I want to step back on this design that we just did. How is this taking in the efficiencies of MEPs, right? I'm guessing you have this built in the space, and it varies depending on the size of the building. Is that correct?
The efficiencies of the MEPs.
Well, in other words, when you're designing this, right, it obviously takes a lot more MEPs for a 65 story building than it does for a 20-story building. So just thinking about how this calculates all of that is what I'm asking.
Yeah. So I mean, look, the one thing about modular that's true right now, and I don't know if it'll ever change, is that there is a little more organization and a little more redundancy than you would have in sort of a conventional process. And what it does by doing that is it organizes the building in a way that's very approachable. But yes, absolutely, when you're talking about buildings and their volume, obviously the complexity of the system greatly increases as you get, from 15,000 to 50,000, from 50,000 to 100,000, and as you get from 6 stories to 15 stories. So it is taking a lot of that into account. Of course, we don't have a perfectly integrated design tool on all of the heat loads, et cetera, although there's some great ones to watch for. There's a lot of work going on in that space.
Sure.
Cove Tool and some of the other sort of great, sort of players in the market. So we again, always, one of the things that I love and I think that everybody should embrace is there's lots of great work going on out there in the construction tech world, and modular is the perfect place to use most of it, way better than it is on a construction site.
Yeah.
And we often challenge the creators of that technology and to try to find ways to make their solution even better so that it can better fit sort of the modular industry. And we've been really successful with the ones that I mentioned today, and we're constantly working with others as well. That's an opportunity. When you're in a factory, you have a controlled environment that allows you to incorporate the value of the technology that you can create.
Yeah, well, I mean, it gives you the opportunity to create, keep optimizing what you're doing and become better and better and pay attention to it, just like the auto industry and every other industry that's in manufacturing, right?
Yeah.
They're not falling behind times typically.
We are trying to catch up really hard. I don't know if we ever will, but it only just gets better. And that's the idea. I mean, what makes me smile is when I go in, to the factory and I'm like, oh, wow, we're now doing this in half the time or half the material because we figured out that this was grossly inefficient or, there were better opportunities.
So let's get to the end of the process. Here we have a building in place. This is something that we haven't really talked about on the show, and that is the facade elements are self-sealing. So if we imagine a 65-story or even 12-story, right, building, and we said, that's a lot of scaffolding. And what you're saying, when this drops drops the wrong word, when we set this in place.
Yes. Don't drop it, please.
It's self-sealing, right? And it's such an old school industry term, drop set, right?
I know. But we have a bunch of things that sort of allow us to do this. So our chassis are made out of steel. They're basically a Varandial truss system, and they are pretty rigid. And the other thing that we have, which is not unique, but it is differentiation, is that we have lifting lugs that stay in place that are part of our modules. So when we set our mods, we lift them up from the top, and we put them down in place. And our solution has a curtain wall system that has a double ball gasket that goes into compression once you put it down onto the mod next to it. And the mod below it, etc. And the result of that, and the ability to make it incredibly accurate, which is of course the risk, allows you to have a building that is completely sealed top to bottom, left to right, as you stack it up, eliminating the need for scaffolding. And there's really no wet work needed as the facade goes up. So when you stack the building, it's an envelope.
I mean, that is just from a personnel and safety standard, especially in city environments, that is a huge benefit.
It is. We have been working with Aon to try to get insurance companies to recognize the safety element of that on a construction site.
Yeah, I can imagine so. All right, so now we have the building in. You put the roof system in. What are you using on roof systems typically to seal it up?
So the final roof system is generally some EPDM, latex roof, etc. I mean, obviously we can do anything. I mean, one of the projects we're working on has a standing seam roof. It doesn't really matter that much, right? So if you think about our modular system, it starts from wherever we're stacking on, whether that be a plinth or a first floor retail space or a parking lot. So we stack the mods. The mods, as you said, self-sealed all the way up to the roof. Right. Includes the parapet, all the shafts, etc. So it's the complete enclosure, and then it basically is topped out, and then the final sort of monolithic roofing system, whatever that is installed on top of our mods.
Yeah. Love it. All right, everybody, hit that like and share button, please, and make sure you're following us on YouTube, LinkedIn, and Facebook. So we're going to look at a couple comments real quick, and then we're going to wrap this up with understanding the post-analysis construction process that you go through and the data collection points. So we're going to continue on a little bit further. Henry Mickelberg says, MEP-wise, it's not unreasonable to allow a project type allowance to use in the basic generative, I can't even say the word, design tool. He's absolutely right.
Yes. Absolutely.
Yeah, for sure. Mark Willy says, Dave Cooper, you became an architect in a few minutes with Roger. I mean, there it is. There's my masters of architecture.
Exactly. But don't hold it against Dave.
Right? Yeah. Listen, I'm only designing it. I'm not the one building it here.
Right.
All right. So, and then Henry's going to wrap up with another comment, and then we're going to jump back in to wrap this up. Anyone who scaffolds any volumetric building above 12 stories shouldn't be playing. Worst case, masked climbers.
Exactly. Yeah. We don't have those too much around here, but they're certainly all over the world.
Yeah, they are.
Yeah.
All right, so let's talk about this. So we have the facade elements or self-sealing. We got the roof on. Now we're getting into post-construction analysis. Walk us through what that means.
Well, I mean, from our viewpoint, it's several-fold, right? One of them is obviously if you're building a modular system, one of the things, the value proposition that we have is is tracking how quickly we do it, and how accurately it's done. And in the event that it is not done so, then we know where the problems are and why they exist. So the advantage of having this digital twin and being able to have and having mateline drawings that shows how they all connect, if there's not that case, then we obviously track it like most people. The good news is that it's a small subset of information that we're tracking, so we can get trends very quickly and we can understand how they work.
So what is a data collection sensor then?
What is a data collection sensor? I mean, look, it sort of depends on what you want it to do, right? So we have ones that collect data on water infiltration. We have data collection on temperature control. We have data collection that just tracks how long it spends on a crane hook. If you've ever seen Versatile Natures, that does the crane tracking, like that's cool. And then obviously even the monuments that we put on our mods as we're lifting them to increase the accuracy of the data collection that's done by our metrology on site. They are integrated sort of to the process.
Yeah, but I think the big takeaway and why my question is, it's not just one data collection. You're collecting data on an entire project, and that's leaving you with the digital twin interface at the end of this project. So you have all this data that you and the user of that building or the building management now has a digital twin of the entire structure. Is that accurate?
Yeah, no, I mean, I mentioned it to you before. Like, we actually know where everything is in the building. And even people who own buildings and are operating in them, sometimes they call us and say, I don't know what to do about this. What do we do? Can we do this? And, we got a call the other day from somebody that wants to install, for reasons we all know today, more airflow in their common area airflow systems. Right. They had a mechanical engineer design a new interface and ductwork for the chillers that are already in the building. And they came up with an idea, 2 options. And they came to us and said, which one's better? Like, and what do you need to do structurally in order to make that work? And, one day later, we were able to say, you don't have to do anything structurally. If you can change the shape of this duct from this to this, you don't have to do anything but install the duct. So yeah, it's incredibly valuable on the long-term process.
Yeah, I listen, I agree. Well, listen, Roger, I mean, there you go. That was 55 minutes. Can you believe how fast time always flies on this show? Exactly. I love it. We have one more person I just want to say hi to. Is Tim Seams. Hello from the treehouse. Love the design tool. Can't wait to try it and see the facade mate line seals. So love it. Tim Seams with John Burns Real Estate now. Love it. I just saw an announcement on that come out. So perfect. Thank you so much for tuning in, Tim, today, and everybody else. Roger, what do you want to leave us with? I mean, tell us what the future is looking like, maybe, and where do you want to see this industry head, and then we'll wrap it up from there.
Well, I mean, my view is that if you're not building modularly now, if you're not thinking about doing it, you're already behind the 8 ball. For multifamily buildings, hospitals, all the things that have sort of a parametric process easily attached to it, you're wasting the time. So you need to embrace it. You need to explore it. You need to engage in it and get on board, because if not, you're going to be left at the station.
Yeah. Well, there you have it. A true professional and somebody who's making it happen in the industry saying that, not me this time. So I 100% agree with that. We're going to go further, faster with people like you, Roger, and we really appreciate you coming on the show and you sharing all that with us. And for everybody out there, if you want to hear more stories and companies about them, go to our YouTube channel and check it out on our product spotlight playlist. You can see a lot more stuff just like this. Roger, you hang tight right there. I'm going to come back to you after the outro and we'll wrap this up. But for everybody else, thank you once again for watching. Thank you for joining us. And thanks for all the great questions. Without you, we can't drive this industry forward. So we'll see you next time. Please join us tomorrow.